Right, let's get started. First thing to do is remove the top panel. Let's put that aside where you can see. Let's have a look at the new 8032 MCU Iflight has started using. More than likely we're going to start seeing these as standard on flight controllers going forward. Anti-spark filter, really nice touch. Not so long ago that was only on premium 6S quads. Really neat soldering, decent amount of cable, overall a solid build. The Runcam R2, no solder connection, which is great for the conversion we're going to do. Moving on to the star of the show, the Air Unit 03. Got this directly from Flywoo, $99, or after conversion, €188. Let's remove the existing analog camera and connectors. It's here. I noticed a bit of glue used to keep the connectors in place. Again, testament to the quality of the budget build. Just use some pliers to gently pry the connector free. Pry the camera loose from the dampening inserts. Here I'm attaching the inserts to the 03 Air unit using the same screws that came with the analog camera. Test fitting the placements before actually assembling it, just to ensure the orientation is correct. Perfect. I screwed this on off camera, the two main screws. Just need to remain the two stabilizing screws. Good and solid mount. Nice bit of tension. I don't like that moving when I'm flying. Perfect. Moving on to sorting out the antenna. The DJI uses an IPEX connector and has two channels, so one for video and one for the control channel. So we're going to have to design and 3D print a suitable mount. Starting off by moving the analog pigtail. Here's the analog pigtail. One side is connected to the VTX. Moving on to creating a custom mount so we can reuse the back end that is already part of the unit. If you have a look, you can see the adapter is basically just assisting with the size and also giving a little bit of extra strength. I'm printing these in TPU. I'll link the STL files down below. Here is the base plate that I'm going to be printing in ABS to keep the TPU in place. Right, let's send this to Orca, which is my slicer of choice. I'm printing this at 0.12 millimeters, which is my preference for TPU. I'm going to keep the rest of my default settings. Overall weight is 0.67 grams. All of these add up to more flight time. I added 3 wall loops at the base. This is where most of the stress would be focused in the event of a crash. Let's take a closer look. 2 small little prints, but that'll serve the purpose perfectly well. Let's take a quick look at the weight gain. .7 grams. Great. Right, this design is just basically intended to be a press fit. The TPU is there obviously in the event of a crash, just to help ensure that the O3 unit antenna is well seated with a little extra protection in the event of bending. Removing the screws for the back end so we can get started on mounting the O3. After giving it a solid push to ensure it's snug, time for the plate. Check everything is seated correctly, nice and solid. Yep, looks good. Mounted, yes, perfect. Instead of cutting to another shot of me designing this in Fusion, this will also be available. I'll add a link of all these files in the description below. Just check how the seating is. You'll notice I added the screws and the nuts. I pre-tensioned those just so that they pull into the TPU. This just makes life a bit easier because otherwise you get the nuts moving around and it makes mounting just generally a bit more difficult. Yeah, we can see the nuts are well seated. Quick check to ensure the dimensions are correct. Perfect. Nice and snug. The unit won't be moving anywhere. Off camera, I fed the cable from the air unit underneath the flight controller. The solder was so good, I didn't want to desolder it. And the size is absolutely perfect with the stock cable that comes with the unit. Here's the challenging bit. Gently, and I mean gently, reattach the cable. If this makes you nervous, probably makes sense to rather just unsolder the flight controller without having to disconnect this. I soldered the air unit off camera. Here's a diagram. You can quickly have a look at the connections. With that out of the way, let's seat the unit. I connected the IPEX connectors for the antenna off camera. I think if I'm going to do this again, I'd rather actually just unsolder one of the sides of the motors from the flight controller and pass the entire unit through. I must have spent a half an hour gently trying to get things together. One thing to note here is that the connectors are under the air unit. The 3D printed mount has this for provision. just a little extra airflow. And there it is, the air unit mounted to the quad. It's quite funny. It's more expensive than the entire quad itself. It's quite a solid mount. I've added 2 straps there just to ensure it's well protected. Right, now we're on the home stretch. Let's assemble the back end to the frame. Last minute inspection before we finish putting it back together. As I'm using this with a remote controller, the DJI one, I'm just going to remove this holder for a third party, just to get a little extra airflow over the air unit itself. Oh, that's better. It was a lot more cramped. Right, let's get ready to connect this up to Betaflight so we can run through the configuration. Very important to notice the fan on the left there. I have fried a couple of controllers previously because they're designed to have constant airflow. I normally use a house fan, but I'm using the silent fan for the video. It's a little bit dodgy. There it goes. Right, just make sure that you provide air when you're working on the bench. Okay, once you fire up Betaflight, you should see COM with AT32. Let's connect. Let's have a quick spin through the vitals over here. What you're going to want to do is go to the presets, search for the O3 preset. Supports 4.4 and 4.5, so we're good. This is the important part, is that we need to select the UARTs that we previously soldered. So select that, pick, save and reboot. Right, let's go through to ports. You can see the port being set up on 1 with the virtual port. Over there, I just connected a GPS when I did this video, so I've set up my GPS. You won't be having any of that. And this is my default config. Go and drag around to your preference. This is mine over here. I'm going to put on the top plate, and then we're going to add the props, and we are done. Satisfying removal of the battery sticker, and apply the battery grip pad. Almost there. Time to add the props. The Nazgul has a default of props out, so just ensure that your orientation is props out. If not, you can always change this later in Betaflight, but I like to keep it stock before I make any major changes. Now we're pretty much done. Just ensure that you tighten your prop nuts. Right, let's just check how much he weighs now. Obviously this is the entire quad without the battery. Okay, it's not so great on the camera, but that is 371. And with the Dogcom S-Bang, that is 611. The battery itself weighs 239. So, and finally, time for the maiden flight. A quick disclaimer, the video that you're seeing here is coming from the DJI Action 2. When I finished the conversion, there was a couple of days of bad weather, so I spent some time designing and printing a mount for the camera. I also added a JetRC M10 GPS. If you're interested in that, leave a comment below and I'll upload the STL files and maybe put a little guide together for that as well. Back to the flights. This handles really well. I'm running the default PIDs. You can't believe it's a budget quad. That's enough from me. Thanks for watching and enjoy the flight.